viewers, welcome back to my channel Stepping Stone Tutorials.
Viewers, please do not forget to subscribe to my channel. It is a very new channel. So please shower your love and blessings to my channel. Also, do hit the like button. And do let me know in the comment section which more chapters you want videos on. Thank you. So viewers, this is the third video on this chapter, chemical effects of electric current. So in the last video, we have seen that electric current do flow through liquids, and it happens due to the presence of ions. So today in this video, we will learn more about ions. Okay, now let me try and explain to you in brief about ions. Let us take the example of a sodium atom. Now sodium, it is represented by the symbol Na, and it has 11 number of electrons. Now in my last video, I've told you what is the structure of an atom. The structure of an atom is that there is a nucleus at the center wherein there are protons and neutrons. Neutron has no charge and proton has positive charge. So the nucleus becomes positively charged. And surrounding the nucleus, there are certain orbits. Okay, and in these orbits, the electrons, they revolve. Electrons are negatively charged. So the structure is similar that of a solar system. The sun at the center and the planets revolving around them. So the electrons revolve around the nucleus. Now let us cite the example of sodium. Sodium has 11 number of electrons. So how many electrons will be placed in each orbit? So I've shown you the orbits here. There is a central nucleus and there are certain orbits around them. So the capacity of the first orbit is 2. So we will place 2 electrons in the first orbit. Now the maximum capacity of the second orbit is 8. So in the second orbit we can place 8 number of electrons. Now 8 plus 2 is 10, but for sodium there are 11 electrons, so that in the last orbit we will place 1 number of electron. Although the capacity is 8, remaining is we have only 1 electron to be placed, so the last electron will go to the third shell. This case is similar to that of just imagine a car which has got 5 seats. Suppose in the first chamber there are 2 seats, in the second chamber there are another 2 seats, in the last chamber there are say 3 seats. Now we have a family which comprises of 5 members. So how will the seating arrangements be made? Suppose you are going to a picnic, then the first 2 members, they will sit in the first chamber where there are 2 seats. Now in the first chamber is fully occupied, right? So no one else can sit here. So the third member has to go to the next chamber, and fourth member will also sit here. So the second chamber is also occupied. So remaining 1 member will go to the third chamber and occupy a seat here. Although here are 2 seats more available, but since we have only 1 member left, he will go to the third chamber and sit there. So I hope you understand, you are clear about how the arrangements is done in case of electrons in an atom. So we have seen that the electronic configuration of sodium is 2.8.1, means in the first orbit there are 2 electrons, in the second orbit there are 8 electrons, and in the third orbit there is 1 electron. Now in order for an atom to stay balanced, an atom always try to become balanced, become stable. In order to be stable, the last shell should contain 8 electrons. Now how can we make this sodium atom balanced or stable? So the sodium can ask somebody to give him 7 electrons. So in that case it becomes 2.8.7. Since the last orbit is fully occupied, 8 number of electrons are here, it becomes balanced. Or what he can do, sodium can say the last electron bye bye, go somewhere else. Then what will become? Its configuration will become 2.8. In this case also the last orbit has 8 number of electrons. this is also a stable state. In both the conditions, the sodium atom becomes stable. So let us again cite the example of the car where 5 people were going on a picnic. The first 2 members, we placed them in the first chamber where there were 2 seats. The next 2 members went to the second chamber where there are 2 seats, and the last member, he went to the third chamber. He occupied 1 seat. 2 seats were remained unoccupied. Now the driver put forward one condition. He said that you bring in 2 passengers from somewhere and fill my third chamber, then only I'll go, Baba. Or you can do one thing, you take away your, you tell your like the last member go in another vehicle, so then only I'll go. So in the first case, if we bring, in the first case, if we bring 2 members from outside, then my car is fully occupied, then I'll go. Or else what you do, the last member you send him in some other vehicle. Okay, so sodium atom is also facing such an issue. So sodium has 2 conditions. Either you give him 7 electrons from outside so that it becomes balanced and the last shell gets 8 electrons, or what you can do, you remove the 1 remaining electron. Now see, if we have to bring 7 electrons from outside and make the configuration 2.8.8, it will require a lot of energy. But if we remove this 1 electron, then the energy required is less. So we will follow the easy path and we will let go the last electron. So if we give away the last electron, the number of electrons in sodium now becomes 10. Sodium gives away 1 electron, and when it gives away 1 electron, it becomes electrically charged and it is now called a sodium ion.